What's up, guys? Long time no video. Haven't been doing too much HVAC related just because I'm not the tech. I just go out for to help techs and things like that. So getting footage from the field is far and few in between now. So half or most of what I've been getting is out on my own at home or whatever, or the drone footage. So I do have another project here I might start here at home. I've had this Friedrich unit. This is a non-VRP. It is like a hotel model, apartment model, vertical. I think they call it a vertical Vert-i-pak. So this has been sitting in my shed. I believe it's never been installed. So I just hooked up some power to it. Got 240 volts. Talk about the voltage here in a second. Got it hooked up. This has one of these little scrolls, you know, to go through like for fault codes. I thought maybe you could also do testing or setup with it, but that's not what it is. It's just for reading faults. So you scroll through like 24 different possible fault codes or whatever. So it's got a couple of them in there when I powered it up. This one here is a fault 2, which is a yes. I guess a 1 means that it's active. So I'll go down to input voltage out of specification. So you have either the 103 to 127 volt for the, 115 volt models, or you got 187 to 253 volts. So what is my voltage here at home on my utility power? Get in there. 253.8. And you think maybe that meter's reading wrong, but I kind of know my neighborhood. Here's another meter. 254 is my input voltage. It's in bypass mode right now, so I guess that's what it's putting out is 254. I'm surprised this hasn't switched back over. I think it probably does about 52 volts. I forgot what my setting is on my solar charger. Put about 1.4 kilowatts into my batteries. So 254 volts. I got even one more I could probably go read. Hold on. Let's go over here to the mess. Should be a couple meters out here. Do I have one in here? Yes, I do. That one's actually lit up. 253, 254. It's kind of bouncing. And do I have one on this? 253. I'm going to cannibalize this and use the slightly larger compressor and some components to redo my heat pump for my water heater now that I have a 240 volt hybrid solar inverter charger in there. People who haven't seen this thing be used a few times over the years, I have a couple different projects. I just use that for the cabinet just to get more room. Waiting to move that one out, but trying to get my trailer through here. Getting rid of the cube heat pumps has been something I've been slowly doing. This unit here is hooked up and is running a couple heads inside the garage. This runs off of solar inverter power. This thing has been, God, I've been using this for at least 4 or 5 years now. I mean, changed it up a few times, but right now, the last iteration of it, I used this old manifold from one of these other units I gutted and kind of made it so I can like switch the valves to use either the outdoor coil for the evaporator or the indoor high wall I have connected, which is what's hooked up now, using just capillary tube for the metering devices on those. And it's been working good. This is a little tiny baby rotary compressor. I mean, it's dinky. Ooh, it's getting hot. So this thing just finished heating water a little bit ago. These compressors have been getting tortured for years. So it's a 115 volt rotary. I think it's like barely a half a ton compressor, maybe a little more, to run this and the circulating pump in there. This thing's running, depending on where it is in the load, it runs like 450 watts to like 600 watts, which ain't shit. It does take longer to heat than the 4,500 watt electric element is in the water heater. However, it takes, it doesn't take like 6-7 times as long to heat as the element does. It takes like 1.5 times as long or something. So it definitely saves money. Run even if it was twice as long to run, 550 watts average, versus 4,500, that's definitely going to be using less power. So I want to have it maybe heat just a little faster. So I'm thinking of rebuilding my deal. These are the pipes that go inside to the water heater tank. Back into the garage. into the project room, which so this is my homemade controller, which it's been bastardized a few times, but it's the original controller up there is still kicking ass. So this is, I just use one of these Amazon temp controllers. Think of like an A419, but for 30 bucks or whatever it costs. That just is my signal logic input to say to turn on, and then I have this thing controlling it. And I do a 2-stage pump. Has to get up to over 100-degree liquid line before it even starts to pump on low speed. That way I get like a heat rise all the time of that cold water, and comes down below, goes through that heat exchanger outside, and then goes back into the top. Sensor's just in here. So running this off of liquid line temp has been working excellent. So I have 2-speed relays on the pump, just for low speed on the pump and then high speed. So I could set it in my controller, so 100 degrees kicks it on low speed, and then once that liquid line gets over 110 degrees, it goes to faster speed. And that's been working. It's like having a thermostat in on your boiler, because you don't want to ever just pass cold water right through it. It's going to take forever to get the boiler hot, you know, and you're not going to get good heat rise. And like in this case, I just ran that pump full speed. Well, it's going to take cold water. It could be this time of year, it's going to be like 40 degrees coming in the bottom there, 45 degrees or so. And it's going to go right through that heat exchanger so fast, it's going to mix right with the hotter section of water right at the top where it's coming out. And you'll notice that in your showers. So because this pump stages based on it building up heat in that heat exchanger, which is a coaxial heat exchanger, it's always shooting like 130 degree water right into the top. So it's working pretty good. So should be even better with a slightly bigger compressor. So I'm gonna take a couple screws out on this and mess with it, see if I could get this thing to manually bump on, just to see that everything works. I assume it has refrigerant in it, but who knows? I've had this thing, you know, for a while. It was in a cardboard box, but it actually got rained on. I took that off. But when I took that cover off, it was like it still had the gasket I had to break loose. So I don't even know if that cover's ever been off. Put some little test jumpers on there just to run the unit. It actually did kick the fan on, even with the voltage the way it is. I got it on low. And for high, what do I have? I got the red. Heard the relay kick over. Just kind of pulls a little more power, but it ain't blowing much harder because there's no static on there, so it doesn't really need it. Should go back to low there. There we go. Motor sounds a little better now. That motor's going to be coming out, actually. Most likely. I noticed that this outdoor fan's running when I turned on the fan. So maybe that's something it does. Oh, it's a dual shaft motor. Just like the window shakers. Okay. That's funny. I might make it a little interesting to, when I cannibalize it, try to simplify it. Might have to put a regular fan on there, depending on which coil I keep. If I keep the cabinet, I might just build my own new little contraption and put the compressor in it, but I don't know. So let's see. Yellow should be cooling. Yellow. There goes the compressor. Got some power there. I didn't even think of putting a thermometer in there. Let's see. I noticed that this has B for reversing valve, and I assume W is just electric heat, which I took the wires off of that. And there's a bunch of leaves and stuff and cardboard slowly shooting out of the fan. Okay, dug my meters out, just got them turned on. One thing I noticed is the probe here that I'm using to measure the outside air, which is the intake here, well, it's above where the exhaust is, and this is condenser air right now. Hot air coming out, feels real good and warm. You notice the outside air keeps going up and up and up. Well, that's because Friedrich is real touchy. So these go in like a wall sleeve that has to have a divider out here so many inches. It's supposed to be accelerating the air through the louvers down and out. Obviously, it would have been better if they would have had the intake on the bottom and the discharge on the top, but you know, so they did. So I'll put this one over here. see if we can hang this over here and get a more accurate outside air / return air temperature, because it's just here like this. That should start coming down. Looks like it got some low batteries. So let that go a second. You can see out the back it's blowing out 95 degrees right there. Out the top's dropping down, it's like 58. And it's probably 70-ish where I'm standing. It's Arizona. Like, you know, Christmas Eve in Arizona. You know, t-shirt weather. So, yeah, someone's gonna get mad at that. So it's working, blowing out some heat. Feels good over here. It's getting crisp up there. I'd say it's a working unit. As I said, I haven't used it, so I'm gonna give it a second. Okay, yeah, it's about 71.8, 71.7, about 72 degrees in the garage. 97 almost blowing out the back of the unit, and about 58 blowing out the top. So it's good. So it's in cooling mode, blowing cooling out there, and condenser outdoor coil is blowing out heat. So it should be the blue wire. So I'm just kind of rigged where I just got some. Okay, it did stop the compressor. Well, I couldn't even hear that. So it's probably going to do a 5-minute delay right now. This is a single phase compressor, of course. Temperatures should start equalizing. Give it a few minutes and see if it switches mode. I'm doing this just for the hell of it, but really, this system's going to get the refrigerant pulled out, copper cut, and it's going to be repurposed. I'm either going to put my components in here and keep this as a cabinet, which I'm kind of thinking I'm going to do, or I'm going to just take the compressor out. But while we're waiting for that, let me show you the other thing I was working on today. This is a heat exchanger I've had for years sitting out back. And if I'm looking at the date code, this actually, I think it says 3/31/2016. So I think this was a good water source heat pump, axial heat exchangers, the water connections are nice and clean. So I just sealed this shut, put on this valve, got it under nitrogen pressure. It looks like it was holding, so left it like that. One reason I'm thinking of repurposing this cabinet is because I can use my knockout set to make the 2 holes for these, and then screw mount and actually install this inside there. Maybe have it going up through the top, make my connections to the top. Not sure. So I got to keep one of the coils, forward evaporator coil, and I got to open it up and see what kind of metering device it has. But it's probably going to get a capillary tube, because that's what I've been using lately because it works so well. And I'd like this to make this into a fully operational heat pump for the water heater with just those 2 water connections, and get this all ready to go, and like mount it out there on the side of the house and just run the water lines and my control connections. So if I do use the outdoor coil, that's another thing I got to debate. It's gonna freeze up the coil like it often did on the other one. Although more surface area, not quite as cold temperatures, it probably should take longer to freeze up. But I should probably make a defrost control to reverse it. Okay, got the top panel off and the side panel's off. And this is funny, remember I was trying to get heat to work. Well, where's the reversing valve? It ain't got one. So evidently this model is a straight cool. So there's your indoor coil. It's got a sensor on it. Outdoor coil, it has a sensor on it. Here's the compressor, which is a rotary. It is a size, what is it? I don't have to look up that number. Oh, there it is down there. So I don't know, it's a 1-ton unit. It's probably like a 10,000 BTU compressor or something, probably. Who knows? But it's a little bigger than the one that's on my heat pump now. And look at this for metering device. That is already capillary tube. Capillary tube coiled up, wrapped in that little sticky freaking goo there. Looks like it's 2 parallel ones. So that's what I would have been making myself from scratch. It's already using it. So probably going to do is gut this section all out of it and then find a way to put in the heat exchanger in here. Might have to shorten it, or it might fit in there like that. We'll see. And then I either put the fittings through the side or through the top. I was kind of thinking the top, because if I set this down low, I'll run the pipes down the wall to it. So there's the blower. The heater has a bunch of shit in it, but it's just a squirrel cage. That part I want to take off. I'm sure these units were real fun to change the blowers on, because you'd have to pull these units out of a closet, tear it down much further than I have it right here. So I don't know if there's a hole in here. Yeah, it looks like there's a spot right there to get to your set screw maybe. And then you take this one off, probably the shroud, and take this motor assembly probably off and pull it out just to change this motor. Oh, but I guarantee your techs are pissed off when they're doing that. So yeah, I might even cut the shaft. We'll see. Go ahead and continue cannibalizing. This is a little bit of a challenge to get all these panels out of there. It took a lot of brackets and plates out of there, getting down to the fan. So maybe I'll go ahead and pull the charge out of it, because I'll go ahead and take this front coil out. Might be another good spot to put the heat exchanger. And I noticed that there's no service port. It's like a refrigerator. Factory charged and sealed. So I'm going to need to actually tap into this myself. I'm going to need to pinch that off and cut it and put a Schrader on there. Okay, we got the pinch off tool on this line coming off the suction stub. It's got another crimp here, and I'm behind that crimp, so I'm going to try to cut this right where we got some where it's still round. Like so. Now, seems like the breed of techs and the experiences they're getting has changed. Whenever I film this and put it on YouTube, people act like they've never seen a pinch-off tool that you could tap into a system while it's charged. Of course, the old-school reefer guys, well, this is just another day for them. See, that little quick little psh, and that's all it did. And even if it leaked just a tiny, tiny bit, as long as your valve you're going to add is, you have the core out, I'm going to use this valve with it open, you could put it in there, and it's not going to have any issues. Because it won't be building up pressure. It'll give you time to braze it. Okay, what I did was I went ahead and punched a hole, punched some mounting screws. I'm going to try to mount this block right here to be my permanent suction line tap. So I've got the service port, getting it close to being closed. Get it real close. Take this off. You hear it hissing a little bit. It's purging the air out of that little section right here. I'm going to go ahead and close that. Alright, it's isolated. Now I need to take and round this out, which I'm not going to be able to hold the camera in it at the same time, but I'm going to go to the pipe size, and then you just use this block. This is the old school pinch-off tool. It has pinch-off tool in the middle. You can go up to like 1/2 inch. And then it's got these 4 sizes. You just basically clamp it over there and round it back out. We'll show you what it looks like in a second. Okay, I had to pull out a little bit on the suction line to kind of get some room out here. Got this one side on there, and then I'll just start clamping down this one. You can see over the years I've had to put the channel locks on there. I'm not able to do this one-handed, but it's already starting to work it. So as I do this, it usually folds it open. I want to show you something though. The difference between using this kind of pinch off or these, which are close to the same thing. See, it's got a round and then a pointed working together. These are not destructive, and you can use this block to round it back out, but the factory uses like a more destructive kind. You look down in here and it's like, dude, I tried to get a bit down there to start working that open, and I just didn't want to take the chance after that. So you can see how their tool looks. I mean, it just devastates that copper with that factory crimp tool, whatever they're using. So I'm going to get this rounded out, and you'll see it's pretty good shape. Okay. Use the vice grips on that a little bit. It's going to be good enough. This is actually a 1/4 inch here, and this copper, looks to be 5/16. And this particular kit does not look that, didn't have 5/16 on it. It was this quarter right to, oh, it is, that is 5/16. Huh, that's what I used on there. Yeah, I knew something looked funny. So 3/8 is loose, 5/16 is kind of a little on the tight side. So I don't know what they had there. But for my purposes, it'll flow good enough for using the service port. So I'm going to go ahead and try to finagle and get this in there and mount it up. And there we go. The line hooked up to the old Infinicon. Wait for that to pull out now, and then I'll go ahead and I think pull the front off and take this coil out. Okay, got the refrigerant all recovered. Now I'm at a dilemma. So my initial plan was to keep this coil for the evaporator. And of course, at first I was thinking this was a heat pump and that the coils were both going to be configured for evaporator and condenser, you know, as a heat pump would be. However, this turned out to be a straight cool. As I've been tearing this down, it just seems like it'd be much cleaner if I use the outdoor coil with the fan and get rid of the squirrel cage section, get rid of this coil. But the dilemma here is this coil here is already set up as an evaporator. And this one right here is set up straight up as a condenser. Now, you've seen on some of my other projects, I've converted condenser coils into evaporator coils a couple times, including that one that's on the side of the house. And it worked fine. Just kind of had to repurpose. Sometimes you got your de-ice loop or whatever, your common subcooler towards the bottom. Sometimes you have to work around or whatever, but you can see most of these just go up and down. Same thing on the other side. Most of these are just up and down until you get down there. I thought that there's a couple of them that cross over the middle, crossing those two middle ones. That might be where that dead ends, and then probably passes just once the parallel circuits, which is 3 going in here. This is kind of odd because this is your discharge. 3 goes in, and they're going to go down. You can see down, and then when he gets to this one's going to hop over to here, and then this one here is going to hop over to here. This one here stays going down until it gets down here, right? So I guess those, I don't know why they're doing it, but they hopped them. Maybe, yeah, because one's after the other ones, and they just do that just to kind of even out. I don't know. Get the most heat out of it that way. So, and that's just 3 circuits. And then you see that they kind of do this thing where they go 3 into 1 kind of things. And they're probably doing is taking the 3 individual circuits and getting them probably into a series pass. So it looks like it probably comes out all together right here is my guess. Series pass. This is all series pass out this line. It's probably just running this pipe underneath, maybe, I don't know, to evaporate some water possibly. And then it steps up to the 5/16 here, almost 3/8. I think this is like in between size right here, same size as this. Goes over, hits this capillary tube coil, just parallel circuits into these 2 circuits here for the evaporator, and it kind of does its voodoo over here. And it comes out, looks like it goes into 2, but then after initial pass, it comes back over. I think these are all straight up and down. So they got a couple crossovers there. So it's going in. Okay, yeah, it's just going in, and so like this line goes in and comes out right here. So it's going to go, and this one's doing the same thing in parallel. They're coming out the bottom 2, and then they hit this U-bend, and they split into 4 circuits, and they're just going up as 4 circuits. Crisscrossing again, swapping, I guess, the side of the coil. I don't know, because you got your warmest air here, coldest air over here. They're swapping those 2 of the 4 parallel. Everything else in the middle stays the same, and then they come out 4 circuits. So that one's already done up as a evaporator, and it's larger tubing. Looks like about 5/16. Well, this looks like pretty much about a quarter. but quarter should be fine for an evaporator also, given this is probably, I still need to look up the size. It's a model 44 A272A. I should look that up. And then here's that other number. That's a serial number actually, so yeah. I'm not familiar with that brand. See what size that is. The unit's a 1 ton, 12,000 BTU, but this is probably like 10 or something. So this coil's more than enough. I could even make it 3 circuits. I just have to totally repipe it though, so I got to see what I want to do. So that's the dilemma. I can use this one and get rid of that one, put the heat exchanger over there, but then I got to put all this back together and seal it, and I took all that apart. But I kind of wanted just to have one axial fan out here to run that. Probably could just, so this motor's made for the static of the blower going through a little bit of duct work. I'd like just to probably put a smaller motor in here, but I use it for an evaporator with no duct static. I don't know. And maybe I'll just not do any of this stuff and just take this compressor out, put it in the unit I already have built, and hope that evaporator's big enough. It might be, because I've actually had a different compressor on there originally, and then had dropped it down to the one that's in there now. It's a little smaller, and that was when I had the first inverter solar charger on there. I was trying to see if it would start better on the other one, and then I found out, you have to look back at some of my videos, but I found out that distortion on the sine wave was making the compressor not like to start very well. Inductive loads did not like it. Transformers made a weird hum, stuff like that. The new solar inverter charger does not do that. So I really abused the other solar inverter charger by starting all sorts of loads. I had 2 different AC units on it at one time, small 1-tonners, but starting a second one while the first one was running and all that stuff, it might have taken its toll on some of the filtering or something in that thing. Who knows? But I don't know. I'll probably think about this. I think I'm going to quit for now and just give this some thought. And I think I'm just losing a little motivation on thinking of repiping this because I'm just getting tired right now. I think if I come out another day, I'll think about this and I'll just start pulling stuff off and just start piecing it back together. I'm pretty good at doing that. Every one of them I've done has worked on units when I've revamped them, or on my creations. They just all seem to pretty much work. So anyway, with that, I guess that'll do it. Don't forget to like, share, subscribe, and comment. Catch you later.